I presented data indicating that aspirin, in addition to inhibit prostaglandin formation, it triggers the formation of other lipid mediators that are also generated from arachidonic acids that are called 15-epi-lipoxygens. The point is that this is a unique property of aspirin among all NSAIDs because aspirin acetylates COX-2, so it blocks the formation of prostaglandins, but on the other side, it triggers the formation of these 15-epi-lipoxygens, which are derived from an intermediate that is formed from the aspirin COX-2 acetylated enzyme, which is the 15R hit. The novelty of these eicosanoids, because they are eicosanoids, they are generated from arachidonic acid, is that they carry anti-inflammatory properties. In opposite to prostaglandins, which are inflammatory, they have anti-inflammatory properties. So aspirin is unique because it blocks the formation of inflammatory prostaglandins, but on the other side, it triggers the formation of these anti-inflammatory mediators. They are really interesting because they not only are anti-inflammatory, they promote the resolution of inflammation. Resolution of inflammation is a part of the inflammatory response that is needed for the full recovery of the inflamed tissue. And this is just a property of that is specific for these 15-epi-lipoxygens. It occurs in vitro, it occurs at different concentrations of aspirin, and in vivo, in experimental animals, also occurs at different concentrations of aspirin. And there is a human study that included 3 different concentrations of aspirin, and the concentration that was most efficient in the production of this anti-inflammatory mediator is the low dose, 81 milligrams. The problem is that aspirin has multifaceted effects, so it's pleiotropic, so it can reduce thrombosis, it is anti-inflammatory, it can reduce cancer and other conditions, so it's important to know the full spectra of all mediators that are modified by aspirin. That's why it's so important to understand the mechanism. Well, the point to go into the clinical is that at present we are designing analogs that mimic these 15-epi-lipoxygens because they have a very short half-life and are rapidly inactivated, so we are designing analogs that are resistant to inactivation to be used as a complementary or as unique treatment for the inflammatory conditions. That's the important point of these new analogs. They will foster the resolution of the inflammatory response, shortening the time that inflammation is resolved. And then this is very important because it's unique for these mediators in opposite to the classical non-steroidal anti-inflammatory drugs. I would like also to add that when aspirin acetylates COX-2, it converts arachidonic acid into these 15-epi-lipoxygens, but this aspirin acetylated COX-2 also recognizes other polyunsaturated fatty acids, especially those of the omega-3. So now we are just uncovering that aspirin acetylated COX-2 can also generate epimers of omega-3 derived lipid mediators that share these anti-inflammatory and pro-resolving activities. So this is a new ground that we are now expanding.